Alrighty, welcome back guys, welcome back to another Go video. Let's do it. So in the last lecture or video, or however you want to call it at this point, I'm just sharing what I'm learning. So in the last video, we talked about web scraping, and then we talked about how we can kind of like calculate some parts of the processing that we have to do in a concurrent fashion, right? And you can see that video, but basically we are looking at we are going through a web page, and then in that web page we know exactly how the structure looks like, and then we extract the data in different Go routines, and that makes it a little bit faster. Cool. Now this is the software, this is the app that we wrote last time, and if I go and run it like that, it will just give you that result, and this every single line of those is actually being passed through, and it's coming from a Go routine. So if I look here, so we have this basically wait group here waiting for the other Go routines, which is going to be here. So this wait group is adding one, and then we are doing the Go routine thingy, and then when it comes back, we are actually printing it. So when it comes back on the result channel, this is where we are printing out that result out there. So every time one Go routine finishes, they will send the result, we print it, finishes, they send the result, we print it, and so on. Cool. Today, what I want to discuss is something about state. So right now we have all these different Go routines. They're going like doing their own thing, and then right now they are sending all this result back into this result channel, and then we are doing something with the result channel. That's correct. That's cool. Now, what happens if I actually want to capture or save those results that are coming through the channel into some kind of container? The issue with that is that what you will find is that the two Go routines might be trying to send back the results at the same time, right? And if that happens, then that means that both these Go routines are trying to access the same memory at the same time, and then you have issues. Cool. And the only way to handle those issues is with a lock, and that is what we're going to be showing you how to do today. So for example, let's imagine that I want to get all these results in an array or in a slice, right? So all these results are coming back through from the channel. I want to smash them in a slice. So the way we can do this is basically we can have a type called let's just call it results. So that type is going to be a struct, that's right. And then inside that struct, we are going to have here maybe job listings, which is going to be a slice, and inside that, job listings, maybe, yeah, job listings, that's fine. And then it's going to be a slice of job listing. So that means we are adding the struct, which is on line 12 there, which is 12 above, right? It's basically a slice of job listing, an array that contains job listing. That's one. And then the other thing I'm gonna add here is some sort of a lock, right? And this is very important. It's basically literally just a lock that is going to protect this data structure so that the person who is trying to add or move or play around with this data structure is going to lock it. And then after they lock it, no other Go routines can attach or do anything with it, and they're gonna do their own thing, and then they can unlock it. And if two Go routines try to attach or do something with this result struct at the same time, what's gonna happen is that they're gonna get queued. So that way we don't have two Go routines doing write operations to this struct at the same time. Now the way you can do this is with something called a mutex. So yep, it's the mutex, right? And that mutex basically has those two properties on it, or like two methods, a lock and an unlock. And we will see how that looks right now. So what we're going to do is basically the moment we are going to wait as normal, and then when we get the results from the channel, instead of printing it that way, what we are going to do is basically lock. So basically what we can do is we can do a new result, right? We can do a new result, yeah. So just call scrap crawler result, right? Crawler result, and this is going to be of type result, that's right, and it's empty there, right there, that's fine. And then once we have that, what we can do is we can do this crawler result dot mu dot lock. So we're going to lock it. I believe we are not going to make a new one every single time. That doesn't sound right. So we have to do that separately. Yep, that's right. So we're going to start one memory location, which is of struct type result. And then what we're going to do every single time we receive a message, we're going to lock it. We're going to lock that piece of result. And then what we're going to do is we're going to go like this, equals job listings equal append. Yes, here we go. Append to crawler results job listing, and then we append the result that we get right back. Cool. And then once we're done with this, what we're going to do after that is actually just print it. Is actually unlock it again. So what we're going to do, crawler results.mu.unlock, right? And we don't need to do this anymore. So basically what happens here is that we are going to start a crawler results struct. So that basically is a block in memory that we keep, and then we're going to lock it. Every time we receive a message in the channel, we're going to lock it. And then after we lock it, we add one job listing to the array, and then we unlock it again to the slice or the array, and then we unlock it again. Okay, cool. So that's fine. And then finally, when we go and we end everything, before we close the channel, after everybody is done, which is basically the wait group is done. So we have this wait group wait, which will wait for everything, and then it will execute the rest after the wait group has returned. So in this case, what we're going to do, we're actually going to print. We are going to print. We're going to print that basically crawler result. Yes, so this is not being defined, obviously, duh. So we're going to print crawler result dot job listings. Cool. And then this is a print format. We don't want to print format. We can just print line. And I don't know if that was going to work. Oopsie, what are you doing there? Let's go here. Oops. Let's go here. Yes, that's right. Okay, let's try that now. So if everything works well, what we will see is that we basically see we will see an array. It's a list, and that list has everything that we saw earlier, but now it's in a list, right? And the idea that happened here is that basically we have this state variable. In this case, it's called crawler result. So this is a state variable, and because it's a state, we kind of like manage it, that different Go routines can lock it, write to it, unlock it, leave it and go. Lock it, write to it, unlock it, or leave it and go. And this is kind of like a shared store between all those Go routines. So you can imagine we have hundreds of thousands of Go routines, and then we need to get some results from all of these Go routines at the same time, and you won't be able to risk have both of them, like 2 or 3 Go routines at the same time, writing to the same memory location. And the way you can fix that is basically using this mutex right there. And this mutex is the one that is going to give you the idea of like literally locking that memory location and then doing something to it, and then unlocking that memory location after you're finished. That's it. So I hope that teaches you something, and I find it interesting. It's basically how to make your Go routines stateful. Cheers. I'll see you in the next one.